Hello, this question is asking us to use our mean and standard deviation to make some statements about some percentages of data. And so what you see down below here, we have our normal distribution and all the percents that are within these standard deviations. So remember, the standard deviation is a measure of spread. So how spread out would this normal curve be? Is it really clumped or is it really far apart? That's what standard deviation tells you. And when you know that information, then all of these percents hold. If you have a symmetrical set of data or a normally distributed set of data, all of these percentages always hold for any set of that type of data. So in order to calculate this, you need to know the mean and you need to know the standard deviation. So we'll go into our calculator. I've already got the data into my stat list in L1 to speed up the video, but you would take your data and you would enter it in there. And then what we're going to do is we're going to calculate the one variable statistics for that data set. And we see here that you have Sx and sigma x in the table there. So this is population standard deviation, and so that is going to be the little sigma x. That's the population standard deviation. If it was the sample standard deviation is equal to the s-axis. So if this statement said sample here instead, you would use the sx number. But for us, it's going to be 7.38 is our standard deviation. So 7.38. Now it does say to round that to the nearest whole number. So that would be rounded down to 7. Right, so we're going to round that down to 7. It just makes the math that we're asking you to do a little bit easier. The same math could be done with the decimals. It's just faster with the whole numbers. And then also you're looking for the mean, and the mean is your x bar at the very top of your 1 var stats. It's the very first thing, and that is 87.1. So 87.1 is the mean. Now it does say to round that to the nearest whole number as well. So I'm going to round that down to say, okay, well now that it is 87. So what does this do for us? What this does for us, that helps us figure out what all of these values are going to be down here. So what I like to do is just, right here, I write all these numbers out. So this is going to be 87, right? Actually, I'm going to go about this right. I'm going to erase, this stuff right here, right? I'm going to change it over and use my numbers that I know. So I know that this is 87, and then I'm going to add one standard deviation, because that's how far this distance is going to be 7 units. So if you needed to use a calculator, of course you could. So you're going to do your 87 plus 7, and I'm going to do that in red. So this is now 94, and then you're going to add another standard deviation, which is 7, which is 101, and add another standard deviation, which of course is 108. So that is 3 standard deviations above the mean. That's what we say. That's, so 108 is 3 standard deviations above the mean. And then you go backwards. So you're going to do your 87 and you're going to subtract 7, which of course is 80. So that's going below the mean. So this is 80. And then you subtract another 7, which would be 73. And you subtract another 7, which would be 64. So all of these values are now marks on our normal distribution. So all of these percentages that you see are how many of the population are going to be between these two values. So what percent of the score should be tested? Should the testing center expect from 87 to 94? So they should expect there should be 34%. Right? So this should be a 34% that they expect to occur between 87 and 94, because you can see that right there, 87 to 94. What percent of score should the testing center expect below a score of 73? Okay, well now below a score of 73, that's everything that's down here. So that's what below is. And so therefore you add those up. So 2.35 plus 0.15. And if you do this work enough, you start to get these values memorized. So that is going to be equal to 2.5% of scores. So what this does for places that use this data is that you can make some statements about where your percentages should be, and also you can see if something's wrong. Like if you expect 34% to be 87 to 94, and all of a sudden it's 10% or something like that, then maybe something is wrong with the test. That's the sort of justification you can make. But in general, standard deviation measures how spread out a data set is. The mean tells you the middle, and so then you can figure out these percentages. So all you do is you look for the numbers you're asked for and add up all of those particular numbers in between, right? So 34% represents the numbers in between those values, and then above you see like between one below and one above, 2 below and 2 above, 3 below and 3 above. Like what's the total amount of percent you would expect